So hello guys, today I am solving the question beautiful matrix from Codeforces and the question number is 263A. So first write down the question number 263A. Question number is 263A and question name is beautiful matrix. Okay. So at first uh, read the question. You have got a 5 cross 5 matrix consisting of 24 zeros and a single number 1. Let's index the matrix rows by numbers from 1 to 5 from top to bottom. Let's index the matrix columns by numbers from 1 to 5 from left to right. Okay. In one move, you are allowed to apply one of the two following transformations on the matrix. First transformation, that is swap two neighboring matrix rows, that is row with index I and I plus 1, or some integers I for some integer I, that is the range of I is 1 to 5. Okay, and the number of rows are fixed, that is there is 5 rows. Okay, and the second operation you can do, that is swap two neighboring matrix columns. Here you can swap two rows. Here we can swap two columns, only one element. Okay, that is j and j plus 1 you can swap for some integer j I2, j is 1 to 5. Okay, so you think that a matrix looks beautiful if the single number 1 of the matrix is located in its middle, in the cell that is on the intersection of the third row and third column. Count the minimum number of moves needed to make the matrix beautiful. Okay, so input um, consists of 5 lines. Each line contains 5 integers. Basically, the input is the total matrix, and in the total matrix, there is only one, means the number of ones in the matrix is 1, and you have to make the matrix beautiful. Suppose let's copy the input, and okay, this is the matrix, and you can see the one is in the and the one is in the index, sorry, here you can initialize, you can write the indices. The index is 0, 1, 1, 2, 3, 4. This is the index, and the same way 0, 1, 2, 3, 4. These are the indices. Right. Yes, these are the indices. Okay, so here you can see the index of the one is the index of the one is index of the one is 1 4, 1 4. Okay, and you have to make the matrix beautiful, and the beautiful matrix is like you can see this is a beautiful matrix. Okay, but the beautiful matrix means the one is in the center of the matrix, means this is a beautiful matrix. This is the This is the beautiful matrix. This is the example of beautiful matrix. So you can see here the 1 is in the middle of the matrix, and this matrix is given already, and you have to make the matrix beautiful. So you have to take the 1 comma 4 index to 2 comma 2 index. Okay, third column and third row intersection here, this is told already. Like, you think that a matrix looks beautiful if the single number 1 of the matrix is located in its middle. Middle means in the cell that is on the intersection of the third row and the third column. So here the third row is this. This is the third row, and third column is this, the index number 2. Okay, so the intersection point is this, the middle. So you have to take the 1 from here to here. So what can we do? Like, you can just simply subtract the indices, the xy point. Like, that the target point is 2 comma 2. The target point here, the target point was, this is the target point, and this is 2 comma 2, and you have to uh, m- uh, you have to find out how many swaps you have to do to get the one here from here. So you can see that you can do one swap here, 1 comma 0. Okay, so suppose I at first the first move you can do 1 0. This is the first swap done, and the second swap you can do 1 comma 0, the second swap, and the third swap you can do 0, and here 1 in the third swap. So total swaps needed is 3. Okay, so basically you have to find out the distance from here to here, the path distance that is not diagonal, that is only using the perpendicular, or you can say using the rows and columns. So the distance from here to here is 1, 2 and 3. So from here, this 1 comma 4 and 2 comma 2, you can see that we have to determine the x change, the change in x and the change in y. Means the change in x, delta x is equal to uh, delta x is equal to 2 and 1, 2 minus 1, and this is 1, and delta y is equal to 2 minus 4, and this is 2. We Here I am taking the change only. I am not taking the subtraction, like things like the difference between this and this. And if you take the delta x and delta y, and after that you can do the total path is equal to delta x and delta y. You have to add the two paths. 1 plus 2 equal to 3. This is the total length of the path, or you can say the total number of swaps you have to do to get the beautiful matrix. So what we have to do, we have to find we have to find the position of 1, the current position of 1. Okay, we have to traverse in the total matrix and we have to find the current position of 1, and after that we have to find the delta x and delta y from that 1. Okay, that that position is fixed, that is 2 comma 2 position, and you have to find that 1 comma 4 position, and after that find delta x and delta y, and after that add them delta x and delta y and find the answer. Okay, so let's begin. Imports is okay. Okay, and let's see what they are taking. They are taking a single 5 rows and 5 columns. Okay, 5 rows and 5 columns. They are taking as an input, and okay, this that is a matrix. So matrix is equal to, or okay, let's take another name like array. This is empty list. Okay, and then I have to take input of the matrix and take input of the content of every row. Okay, so for I in range 5, we have to take the 5 columns. 5 and dot append what to append, we have to append 5 list. Suppose this is a empty list. Okay, this is an empty list and I have to append 5 list which exist, like I have to append 5 list with every list contains 5 integers. Okay, so we have to append list map int input split. Done. We have we have took the list input on, we have took the array input, the matrix. So let's create a function to find the length or find this total number of swaps. Def count swaps. As an input it will take array, and we have to traverse on the array and we have to find the index of the 1. Okay, so for I in range 5, we have to use the nested loop because this is a 2-dimensional array. G in range 5, and after that if error of I j that is equal to 1, if you got the 1 then store the indices. Okay, then store the indices means suppose r row column rc equal to 0 0, initialized row and column with 0 and 0, and here rc equal to I comma j. You have stored the indices of ij. Okay, and then break. Okay, now delta x, what will be the delta x? The delta x will be what value? ABS, absolute value of r minus 2, x means row. Okay, r minus 2 delta y absolute value of, here I have taken 2 because 2 is the middle position index, column minus 2. Okay, so return delta x plus delta y. Okay, now I have to print what to print in the length. Okay, print what is this, count swaps and then error. I think this will work fine. Now we have to input the matrix. This is giving 3 and 1. I think this will work. Okay, accepted. And you can see the all test cases here. Okay, then goodbye.